Alright, good morning. So we only have two things left to do. The first is going to be to graph logarithmic functions, and then we're going to get into a few word problems working with growth and decay and all that fun stuff. And then we would have covered everything in the Algebra 2 curriculum. So awesome job sticking with it. So let's start off with a quick recap of exponential functions because there's going to be a very, very close relationship. So this was an exponential function. Just to recap some of the highlights, it's going to go along the horizontal axis because remember it plateaus eventually and then it exponentially increases. Now when we talked about graphing exponential functions, we talked about a couple different ways to do it. One was the plugging in method and the other one was using the table. Today we're going to focus on using the table. So just to review and refresh, you want to look for kind of the foundation of the table. With exponential functions, it was the base, and then from the base we could plug in -2, -1, 0, 1, and 2, and then when we plugged it into just something like 2 to the x, we got the y values. Then from there we followed what we had. So the dilation multiplies the y, this exponent is the horizontal shift, you set it equal to 0, and this is the vertical shift. And so you can apply it as you need to, and then you have your table with your exponential function. What we're going to be doing today are going to be logarithmic functions. Now, let's say I have y equals log base 2 to the x. My first step is going to be to rewrite this into exponential form. So I'm going to rewrite it to 2 to the y equals x. Then, just like an exponential function, I'm going to plug in -2, -1, 0, 1, and 2. However, the x and the y have switched. The y is now the input and the x is going to be the output. Now if you recall, what happens when you have a function and you just switch the x and the y? Those are the inverses. So that means that a logarithmic function is the inverse of an exponential function. So when you switch the inputs and the outputs, the result will be each other. So after I set up this table, my third step is going to apply any shifts or dilations to the table. We didn't have any, so I simply plot the points and graph. Now you can kind of see how it kind of resembles an exponential function. Instead of it plateauing along the x-axis, it's plateauing along the y-axis, and then it starts to plateau. Now this logarithmic function is kind of the perfect representation of what people have been talking about plateauing the curve with COVID, is that eventually it's going to plateau and there won't be a steady increase of cases, or this is also used in population models. Eventually populations need to slow down. So here's an example of a logarithmic equation with dilations and shifts. So I'm going to follow the same steps I just went over. My first step, I'm going to ignore everything but the base. And so I'm going to say 2 to the y equals x. And then I plug in a table just like I had. Now I'm going to look at my dilations and my shifts. I'm going to multiply the y's by 2. I'm going to subtract 1 to the x, and I'm going to subtract 3 to the y. And so here's my table. I started off with these right here. Subtracted 1, multiplied by 2, subtracted 3. So then I get all my points. And when I plot them, instead of it plateauing along the y-axis, I shifted this all over 1 unit to the left, so now it's plateauing along x equals -1, and then it starts to plateau from there. So that's a logarithmic function. So here are 3 problems. I try to make them pretty similar so you don't have to keep changing your base function. So log base 3 to the x, log base 3 to the x plus 2 minus 1, and then negative log base 3 to the x minus 3 plus 1. Good luck, you're almost there.